Hi, good day. I'm Amy Fuchsteiner, and this is Elementary Algebra. We are going to take a look at section 5.5 today, which is combining like terms, adding and subtracting polynomials. So to begin with, we'll take a look at what a like term is. Speaking algebraically, like terms are two terms that contain the same variables to the same power. Oops, I'm writing crooked. Ideally, if they do not have the same variables or the same power, they're simply what we call unlike terms. Now, like terms can be combined. Unlike terms cannot. So if your terms are unlike, the only thing that you can do is restate them. Who's going to the park? Bob and Sue. They're completely unrelated, so you just say Bob and Sue. But if they were twins, you might call them by the Smith twins. You might call them by their collaborative or group name. With like terms, we can combine them to call them by one name. With unlike terms, we cannot. We simply must leave it as two or more separate things. So how do you tell like terms from unlike terms? Well, here I have 4 quick examples that we will look at and analyze to determine whether or not they are like or unlike terms. If you're looking at 15x and 15y, the variables are different, and that's how we determine whether terms are like or unlike. So because these variables are different, we would say these are unlike terms. We cannot combine them. 15x and 15y is simply 15x and 15y. We can't say it any other way. If we have 4 chairs and 2 tables, we don't suddenly make them chables. It just does not work. All right, problem number 2, we have an x squared and a 1/2 x squared. Notice they both have an x and they are both to the same power of squared. That's all that matters for like terms, that the power and the variable be exactly the same, x to the second, x to the second. So these would be considered like terms. With number 3, we have a negative 2xy and a 6y. One has an xy, the other one just a y. Because those variables are different, this would again be unlike. A 0.0xy squared and I think that was 0.2x squared y. The same variables are there, the x and the y, but one is to the first power, just a singular x, and a y to the second power, and the other one is an x to the second power y to the first. Because we've switched up the exponents there, these would be considered unlike terms. Now, when you have terms that are like, you can simplify them. That is, you can collect them and put them together. What does that look like? Here with number 5, we have a 15x to the 4th plus another x to the 4th. It's important to note, as we've talked about in earlier sections, that if you have a 15x to the 4th plus an x to the 4th here, this represents a singular or one additional x to the 4th. So if I have a 15x to the 4th plus one more x to the 4th, this will give me a total of 16 x to the 4th. Because these are like terms, I can combine them. That does not do anything to the variable. It only does something to the coefficient or to the multiplier. If you had 15 chairs and you added one more chair, that would give you 16 chairs. Substitute x to the 4th and you have 15x to the 4th plus one more x to the 4th will give you 16 x to the 4th. Okay. Problem number 6, I have 12pq squared plus 5pq squared plus 8pq squared. Notice all of these are pq squared. So with all of those being pq squared, I can do just what it says and add them. 12 plus 5 is 17. 17 plus 8 is 25. So this would be 25 pq squared. Number 7 represents a slight challenge because we have different terms. I have a 4x squared plus 2x plus 1 plus x squared plus 5x. Now, I want to combine those that are alike. Here I have an x squared. That is not like an x. So 4x squared is not like 2x because this has a second power on it and this one does not. It is, however, like the x squared here. So some will prefer to rewrite it as 4x squared plus 1x squared. And then we'll take a look at the 2x, which has a friend over here with the 5x. And then we have just a plus 1. So if we were to combine like terms, we could combine the 4x squared and the 1x squared to give us a total of 5x squared. We could combine the 2x and the 5x to give us 7x and a plus 1. This then becomes the entire answer, 5x squared plus 7x plus 1. Let me put a box around that so you can tell. That's the whole answer. I can't add the x squared to the x's, and I can't add those to the constant of 1. So I would just leave it. All right, if I look at problem number 8, I've got a 7. That's a constant. I can combine that with a 3, so I can do a 7 plus 3. I've got a 3xy squared, and I've got another xy squared here. So I could do plus 3xy squared plus, and I'm going to write the 1xy squared. That's fine. And then here I've got a plus 2y. It does not have a partner, so I'll just leave that. That means that I can put this together and combine it. I've got a few things. Remember, we talked in an earlier section about order. So I'm going to combine the 3xy squared plus 1xy squared to do a 4xy squared. Then I'm going to do the plus 2y. I'm paying attention to the descending order, plus 10. I cannot combine the xy squared to the 2y or to the 10. So this is as much as I can do to simplify this problem. I know it's a little bit disconcerting and you want to like mush everything together and get one answer. It's sort of like the blessing and the curse of algebra. I always like the fact that I could stop thinking about it. But yeah, I understand if you want to mush it. You just can't right now. Okay, we'll do the same thing with our second goal, which is subtracting them. So whether you're adding or subtracting, we do the same steps. Here I have 15x to the third minus 13x to the third. Notice these x to the thirds are the same, so I'm just going to combine those coefficients or multipliers. 15x to the third minus 13x to the third is indeed 2x to the thirds. If I have 2x squared minus 5x squared minus 3x squared, they are all x squareds, so I can just pay attention to the coefficients. 2 minus 5 minus 3 would get me a, let's see, 2 minus 5 is negative 3, minus 3 more is a negative 6, x squared. Oh, let's move this. Number 11 got a little messy, it looks like. So we're going to do a minus 2m up here. Okay. All right. When you're looking at number 11, you should see again that we do not have like terms. So not everything is the same. What we want to do is we want to group either in writing or in our heads the things that go together. So I've got a 12m squared and an 8m squared. So I'm going to take the coefficient, so 12m squared, and then I'm going to take the sign in front, minus 8m squared. And that takes care of those two. I'm going to grab a different color here. Let's try the green. I don't think I've done much with the green. And then I've got a minus 8m and a minus 2m. Those two are alike. Notice I'm keeping the minus signs from in front. And then I just have a single minus 10 tacked on here at the end. So when I go to combine things, The 12m squared minus 8m squared will leave me with 4m squared. The minus 8m minus 2m will give me a minus 10m. And then I have another minus 10. This is as far as I can go because I cannot add m squareds to m's. I cannot subtract m squareds to m's, so that's where I leave it. All right. Problem number 12, I have a 1.5x squared y minus 0.7x squared y minus 4.2xy squared. Okay, I'm going to go careful here. Got an x squared y and got, okay, so these two are exactly the same, meaning I can do the 1.5 minus 0.7. That's going to be 0.8 x squared y. And again, I have practiced doing this, so if you need a calculator, please do not hesitate. Use that calculator. And then I've got a minus 4.2 xy squared. This is a different power than these, so I cannot do anything, and I would just leave it 4.2 xy squared. All right, fantastic. Let's kick things up just a little bit. So we're going to add some polynomials. We're going to take two distinct polynomials, the 3c squared minus 2c minus 5, and we're going to add that to the 4c squared minus c plus 13. We're going to do it the exact same way we did the others. The parentheses, just make sure that you have distributed if you need to. Okay, so we're going to do the 3c squared plus 4c squared. Those are my like terms. I'm just going to put them together. Now, whoops, that should be a 3. Thank you, Amy. Some students will draw a simple line through them to indicate that they've used them because there's a lot to look at. So if you need to do that or like to do that, that's fine. Then we've got a minus 2c and a minus 1c. We've talked about this before. If there's only one of them, you can put the 1 in front if it helps you to remember. And then my constants, I have a minus 5 and a plus 13. So now I'm just going to go ahead. Oh, I didn't draw through those. I might draw through those. All right, 3c squared plus 4c squared is 7c squared. Minus 2c minus 1c is minus 3c. And I've got a minus 5 plus 13, which is 8. I cannot combine a c squared with a c, so this is it. I'm done. All right. Then we've got a 4q squared minus 7 plus 8q squared plus 2q minus 1. If I've got a 4q squared, I've also got a plus 8q squared. I've got a minus 7 and a minus 1. Do you see what I mean about how if you don't cross things out, it can be a little confusing? So even if you started the problem, feel free to go ahead and take the 4q squared and the 8q. I've done both of those. I've done the minus 7 and the minus 1. And then I just have left a plus 2q. If you don't find the cross out piece helpful, you don't have to use it. I'm just trying to give you some options. All right, so we've got a 4q squared and an 8q squared for a 12q squared minus 8 plus 2q. Now, it should be noted that mathematically, the correct way to write this in descending order is the 12q squared plus 2q minus 8. As we've talked about previously, this is not an incorrect answer. The notation is a little bit off because we want to write them in descending order. So just watch out for that, please. All right. Problem number 15 is the same problem as number 11, but we're going to talk about what's known as vertical form. I don't want you to freak out about vertical form at all. It's just a way of rewriting the problem. Some students prefer it, so it is an option, not a mandate. But I want you to be aware of what it is in case you see it and you don't freak out that it's something different. I want to kind of expose you to as many different options of this as possible, so that hopefully when you get to that, you don't feel overwhelmed if you should see it in the assignment or in the test. So the vertical form just simply means we rewrite the first one, 3c squared minus 2c minus 5. And then, like you used to do with fractions, many of you used to do with fractions, we will now put the like terms underneath each other. So we'll do 4c squared minus, I'm going to go ahead and put the 1 in because I think it's helpful, and then plus 13. And sometimes you will see these underneath each other like this, just like old school addition with numbers, where the like terms are directly underneath each other. You probably did it with decimals in place value, where you lined up the decimal points and put things. This is that idea, okay? Now, because we're adding, I'm going to do a big old plus sign. And then I can just add. This is 3 plus 4, which is 7c squared, minus 2 minus 1, which is a minus 3c, minus 5 plus 13, which is a positive 8. Lots of people like this because it's super slick and it's really easy to see things. I find that going horizontally is the same, so I'm not particularly a huge fan of it, but I do recognize that it works for a lot of people. Here I have a 4q squared minus 7. Now, here's where the vertical comes in handy. Remember when you're doing decimals and there's something up on the top and you fill in with zeros? Do you kind of remember that? So this is a 4q squared. I'm going to do plus 0 q's minus 7. Because remember, we had a descending order. So if we've got a squared, q squared, then the next one should be q, and then there shouldn't be any q's. So because I'm missing that middle term, lots of times people will put in 0q here. Then when I line it up, I've got an 8q squared plus 2q minus 1, and I have a place value for it, just like I would if they were numbers. Now, because I'm adding, I get a 12q squared plus 2q minus 8. This particular skill of knowing when to put in the zeros is really helpful for something we're going to do in like 3 sections. So at the very end of this unit, there's something where we'll need this particular skill. So I'm not just throwing it at you for nowhere. Okay. All right, subtracting the polynomials. We're going to find the difference. We need to be a little bit careful with the difference. So here's the idea. We've got the 5x minus 12, and we've got one of those, right? So since there's one set of parentheses, this is 1 times 5x, which is 5x, and 1 times the minus 12, which is the minus 12. But here I'm subtracting. If you put a 1 in front of there, then when you distribute it, you get a minus x and a minus 1 times a minus 7, which is a plus 7. Okay? That's one way to think of this. The other way to think of this is not only are you subtracting the x, but you are subtracting a subtract 7. And we know that minus a minus switches it a plus. So when you subtract subtraction, you get addition. Subtracting subtraction. Reversing the reverse. You're back at the original. Now I can treat it just like I did with the addition problems. I can take the 5x and combine it with the minus 1x. And then I can take the minus 12 and combine it with the plus 7. This will give me 4x minus 5. Right? Similarly, with number 18, I've got just one of the minus 3x squared plus 5x minus 7. And then I'm subtracting the x squared, which will be a negative x squared. And I'm subtracting a negative 6, because I have to subtract everything that's in that parenthesis. So I also have to subtract a negative 6. Minus a minus 6 is plus 6. So I've got a minus 3x squared, and I've got a minus 1x squared. I've got a plus 5x, Then I've got a minus 7 and a plus 6. This is going to give me a minus 4x squared plus 5x minus 1. I cannot combine my x squareds with my x's, so this is it. I can't do anything more with this guy, and I am done. Oh, this light needs to come on. Oh. Okay. I'm just going to put a red box around that and go. Red box it, and we're done. We can also subtract in vertical form, much like we did before. So we're going to rewrite. Well, okay. Ooh, I forgot about this part. Okay. So we have to think really closely about the word from. So if we're going to subtract 2q squared minus 2q minus 8 from 4q squared plus 8q minus 7. The order is important. If we're going to subtract 4 from 10, when you subtract 4 from 10, what do? You're subtracting 4 from 10. Is that 10 minus 4, or is that 4 minus 10? When you subtract 4 from 10, you actually do 10 minus 4. And I point this out because that's the reverse order from the way it was stated. I would like to, from the part of mathematics, simply state that this is not a math issue. This is an English issue. So if you are in your head going right now, math is confusing, I would just like to defend mathematics by saying this is English. The fact that the subtract 4 from 10 switches the order is not a math problem. It's actually an English issue about the preposition. I think that's preposition. From. Okay? Got to defend what I love. All right. So what that means is when you see the word from, we're going to write this first. We're going to write down the 4q squared plus 8q minus 7. And then from that, we are going to subtract the 2q squared minus 2q minus 8. But the thing is, since we are subtracting all of this, what happens is all of these signs get changed, and then this becomes addition, right? Because subtracting is adding the opposite. Subtraction is defined as adding the opposite. So now when I add them, I get a 2q squared plus 10q plus 1. Okay. All right, problem number 20 says to subtract d squared minus 9 from the sum of d squared plus 7d, not t, and d squared minus 11. So if we're subtracting this from the sum is addition. So first we're going to add d squared plus 7d plus 2d minus 11. And that's going to give us d squared plus 9d minus 11. From that, we're going to subtract d squared. Oh, I don't have any d's. Plus 0d minus 9. Since we are subtracting them, that's the same as adding the opposites. Notice how I'm doing it in a different color? Lots of people do. That just tells me that I did that. Like I completed that step. It's sort of a visual cue that I got that step done. And then when I add them, I have a d squared minus d squared gone. So that's 0d squareds. Then I have a 9d minus 0. That's 9d plus. And then I have a negative 11 plus 9, which is a minus 2. So I don't need this. 9d minus 2. Done. All right. We're still going. We're going to keep trying a few problems here. Now, we're going to add in some distribution before we do the addition and subtraction. So, let's see what we've got. I've got 3 of those here. Simplify it 2 times the quantity x plus 3 plus 4 times the quantity x minus 2. This becomes 2x plus 6 plus 4x minus 8. 2x and 4x is 6x. Plus 6 minus 8 is a minus 2. I cannot put together the x and the minus 2, so I'm good. Right? Problem number 22 is a negative 2m squared plus 7m minus 1 minus 3 times the quantity m squared plus 2m plus 2. So this will be a negative 2 times m squared and a negative 2 times 7m, negative 2 times 1, minus 3m squared, minus 6m, minus 6. And once I have everything distributed, then I can combine my like terms. Got a minus 2m squared minus 3m squared. It's a minus 5m squared. Minus 14 minus 6m is a minus 20m. Minus 2 plus 6 is a minus 4. Negative 5m squared minus 20m minus 4. I think I've got all my signs right. You guys will tell me it, right? You'll send me a comment if I've got a little mix up, because it's entirely possible. All right, problem number 23. I've got a 4 times the quantity z squared plus 3. That's a 4z squared plus 12. Minus 2z plus 6. So that's going to be a minus 2z. Negative 2 times a positive 6 is a minus 12. Then I've got a minus z squared minus 5z. So that's going to be a minus z squared. And then minus a minus 5z is the same as plus 5z. So I'm effectively distributing a minus 1 there, if you like that particular thought process better. Minus 4z minus z squared. So I've got this guy and this guy. Now this, remember, is a 1. So 4z squared minus 1z squared is 3z squared. When there's a lot, I tend to put a line through it. I've got a plus 12 and a minus 12. Ooh, sweet. That zeroes out. And then I've got a minus 2z plus 5z. And that's a plus 3z. Minus 12 minus 2. Yep. Okay. There we go. Like terms. I cannot combine the z squared with the z. I am done. That is good. All right. So, a couple of application problems. No big deal. We can run through. All right. Problem number 24 says to find the polynomial that represents the length of this fan belt. Oh, there are pi's and there are x's. Okay. Don't overcomplicate it. The length of the fan belt would be all the way around the belt. And I'm just going to be adding things up as I go. So what we want to do here is, I'm going to start with the easy stuff. I'm going to pick a corner, pick a starting point. Let's start here. And I'm going to pick a direction, which means I'm going to go around this way. And then I'm just going to write down all the pieces because I'm just adding them together, right? So I'm going to do 1.5 pi plus, and I'm just going to put a check mark there, x squared plus 9x, and I'm going to put a little check mark there. That's just to show that I've written it down. Plus 2 pi's plus x squared plus 5x plus another pi here plus x squared minus 3x. And I'm back at that green star, so I know I've incorporated everything. Now, looking at all of this, I can simplify. This isn't wrong, it's just long. So I'm going to go ahead and see if I've got some like terms. Here I've got a 1.5 pi. Now, I know you know pi as 3.14. That's not exactly what pi is. Pi is infinite, so there's, when I say infinite, I mean there's an infinite number of decimal places. It goes on forever and ever. So oftentimes for pi, we simply use this little tabletop double T sort of figure to represent it. And when we do that, we treat it like the same way we would a variable. It's not a variable, but we treat it the same way we would. So I can take a 1.5 pi and combine that with 2 pi's and combine that with my 1 pi there. And if I do 1.5 pi plus 2 pi plus 1 more pi, that's going to give me 4.5 pi's, right? I've used all my pi's. And then I'm going to take the x squareds. And each one of these is 1. Hey, look at that. And so that's going to give me 1, 2, 3 plus 3x squareds. And then I've got a plus 9x and a plus 5x and a minus 3x. 9 plus 5 is 14. 14 minus 3 is 11. Okay. This is fine. To put it in the proper order, I would start with the 3x squared because that's my variable to the highest degree. I would then do the 11x and then the plus 4.5 pi. There we go. And until I know what x is, I can't figure out what this length is. All I can do is leave this. Now, Amy, why didn't you do the 4.5 times pi? Because I don't know how many decimal places we need. If it's just us in a basic math class doing the calculation, yeah, 3.14 would be fine. But if this is actually for somebody who manufactures this belt, they might need a much more precise measurement. They might need 3.1415. I mean, they may need to take it out 6 decimal places in order to get the cut or the precision correct. So I'm going to leave it just as pi because I don't know who it's for. And yeah, somebody can easily come along with a calculator and type in 3.14, right? Okay. 25 looks interesting. Let's see. 2 warning flares are fired upward from different parts of a ship at t seconds. So t is representing the number of seconds. The height of the first flare is represented by the polynomial f of t is a negative 16t squared plus 128t plus 20. Okay, so this sort of mess of f of t, this represents the height of that flare after t seconds. So it's describing what is likely an up and down, right? Because that's what happens when you shoot a flare. It goes up and down. It's different from the second flare, which has a height of negative 16t squared plus 150 plus 40. I don't know how many t seconds there are. Find a polynomial that represents d of t, the difference in their heights. Oh, I know what they want us to do. Do you? Okay, what do you think? Do they want us to add them or subtract them? Remember, we're in 5.3. We're adding and subtracting polynomials. They're giving us polynomials, and they're asking us to create a new one that represents d, the difference. So, since this section is about adding and subtracting, and they've said difference, I am going to go out on a limb here and say that the skill that they want you to practice is subtracting the 2 polynomials. So we've got f of t is a negative 16t squared plus 128t plus 20, and the second one is a negative 16t squared plus 150t plus 40. So I'm going to say that I need to subtract. So I'm going to do a negative 16t squared plus 128t plus 20, and I'm going to subtract a negative 16t squared plus 150t plus 40. Now, since I'm subtracting them vertically, that means subtracting is the same as adding the opposites, plus, minus, minus. And that's going to give me 0t squareds minus 22t minus 20. So I'm going to say that d of t, the difference between them, is a negative 22t minus 20. Yes, I left off the 0t squared. And I left that off because, well, we don't need it. 0t squared is 0. In 4 seconds, the first flare will reach its peak. What is the height of the second flare? So what is the height of the second flare 4 seconds in? So 4 seconds is my t. So this is, okay, I got organized a little bit. So that's my A. B would be the second flare at t is equal to 4. So that's going to be a negative 16 4 squared plus 150 times 4 plus 40. It's a good thing we did a little bit of this plugging them into the functions, right? Okay, so this is going to be a negative 16 times 4 squared, which is 16, plus 150 times 4, which is 600, plus 40. 16 times 16. Oh, I don't have my calculator. I want to say it's 256. I found my calculator. Hey, look at, there's a light there. 16 times a negative 16. Yeah, we go. So this is a negative 256 plus 600 plus 40. Or 384 feet. There we go. All right, so I figured out that I needed to subtract the polynomials to make the new one for part A. And then for part B, we just were given a time of 4 seconds and then asked about the second flare. So we knew t would equal 4, and we put that in to the second polynomial function to get 384 feet. Okay, that covers the bulk of what you'll see in section 5.5. If you have any questions or concerns, please don't hesitate to reach out to me or to contact the Math Center to get a little bit more assistance. All righty, thank you. We'll see you in 5.6.